Alright class, welcome to handout 4.2 on triangle congruences. We'll begin this handout with ways to name corresponding sides of triangles and corresponding angles of triangles, and how to name congruent triangles. Okay, so zooming in on number 1, we have two triangles ABC and triangle XYZ. The marks on the sides are little tick marks and they correspond to each other. So if there's one tick mark on this side BC, it will be equal to the tick mark, which means that it will be equal to the side XZ. If there are two tick marks on a side, then that between two figures here, two congruent triangles, so AB is also corresponding with side XY. Now three tick marks will show also another correspondence, so this is side AC and side YZ are also equal to each other. Okay. No matter the orientation, the marks help us know which sides are equal. Also, the angles are equal. We're going to go with purple. Angle A has one mark on its angle. So does angle Y. Those two angles between these two triangles are the same size. They're equal. Angle C and angle Z have two marks on their angles. That means that they are equal. And angle B has three marks on it. So does angle X, has three marks on it. So those angles are equal. Moving down to our list of correspondences, two triangles can share the same length angle, same size angles and the same length sides. So angle A has one mark in the first triangle. That corresponds with the angle with this single mark in the second triangle, which was angle Y. Okay, and recall that we can name the angle after the point if it is the only angle that has that vertex, and so these triangles do. Angle B is three green marks on it, so it corresponds with angle X that also has three green marks on it. And angle C has two orange marks on it, and angle Z has two orange marks on it, so they are equal. Now we can look at the sides. AB has two blue marks on it, so it corresponds with the side that has two blue marks on it in the other triangle, which is side XY. Segment XY goes there, good. BC has red mark on it, so it corresponds with the red mark XZ. So segment XZ is what BC corresponds to. And segment CA is three yellow marks, and so it corresponds with YZ, which also has three yellow marks on it. Segment YZ. Now those are correspondences, relationships between a side, or an angle and an angle, in two triangles. The congruence statement, congruence is a word that means the same size and shape. Okay, so it's like super equals, and that's why we have two marks there as the equal sign and then a little squiggle on top of it. That means the same size and shape. So triangle ABC is congruent to triangle XYZ. And for this class, it doesn't matter the order of the letters. Just make sure you have all three of them from the triangle you want to talk about. That means that they have the same size and shape. If each of the angles are the same size, and each of the sides are the same size, then that means the triangles must be congruent. Okay. Let's go ahead and go to number 2. And number 2 has similar ideas where we have 3 different marks for each side, 3 different marks for each angle, and you want to sort them out on these specific 2 triangles to say which angles are equal, which sides are equal, and then writing a congruent statement. Okay, so go ahead and pause the video and try it out. Okay, now that you've resumed the video, hopefully you have all of the correct correspondences. So correspondence between angles and angles and sides and sides. So angle D has 1 mark on it. Angle M has another mark on it. Angle E has a mark on it. That's the 90-degree angle mark. But we also look for one in the other triangle, so that's angle L. Angle F has 2 marks on it, so angle N is the corresponding mark there. Let's see, DE. DE has 1 mark on it right here. Let's look for 1 mark over here. LM. So segment LM is what DE would correspond with. And so we're going for orange. There's orange. EF has 2 marks on it. And so we look for the side that has 2 marks on it is LN. Segment LN. Okay, it doesn't matter the order on the segments or on the triangles. And then the last one is a side that has 3 marks on it, FD. Okay, which side has 3 marks on it on this one? MN. Segment MN. Good. When we're writing our triangle congruent statement, we say that triangle DEF is congruent to LMN. LMN. Triangle LMN. Okay, so we have one more. Zoom in on this one. Go ahead and pause the video, sort out all the correspondences, and write a congruent statement. Okay, so let's take a look at this one now again. That you've resumed the video. Angle R has 2 marks on it, so angle W is the one that has 2 marks. Angle S has 1 mark on it, so we need the 1 mark over here, angle U. Angle S corresponds with angle U. Angle S is equal to angle U. Angle T has 3 marks on it. Angle V has 3 marks on it, so angle T is equal to angle V. Okay. Side RS. Side RS has 2 marks on it. Side WU has 2 marks on it. ST has 3 marks on it. So side UV has 3 marks on it. Side TR has 1 mark on it. Side VW has 1 mark on it. Okay. So in our triangle correspondences, we set up 6 correspondences, 3 angle correspondences, and 3 side correspondences. Therefore, triangle RST is congruent to triangle UVW. Okay. So that's how we're going to name our sides and our angles in this section 4.2 and 4.3. We'll take a pause here and go to a different video format to explore triangles and congruences to finish out our handout. So we'll do an exploration first and then we'll finish our handout. Okay class, this is the exploration on triangle congruences from section 4.2 in our book. Now we need to identify whether or not in any figure or any homework problem or any part in life, if two triangles are the same size and shape. They could be in different orientations, and so that's the tricky part. In our 4.2 naming worksheet exploration, we're able to show that triangles are congruent by establishing equality between and correspondences between the angles and sides. Okay. So angle A corresponds with angle D. B corresponds with CE. C corresponds with F. Okay. As far as sides go, we have AB corresponding with DE, BC corresponding with EF, and AC corresponding with DF. Okay, so I've made the appropriate marks. So how many of these sides and angles do I need to show that the triangles are equal or congruent? Okay. Do I need to show that all 6 correspondences are the same to force everything to be congruent? Can I do it with 5? If there is one of these correspondences that is not shown or proven to be equal, will the others force that one to be equal? What about 4 correspondences? If I do not show that 2 correspondences are the same, are equal, would the other 4 force the other 2 to be equal? And so on. So our question is, how many correspondences do I need to make to show that the triangles are congruent? Okay, so for that, we're going to go ahead and start at the beginning. We need to establish a pattern in mathematics. This first one is called the one correspondence. Is it possible to just have one correspondence between 2 triangles and force the other 5 to be the same? Which means that if I can find a counterexample, meaning, is there another triangle that has the same correspondence as the first, but with varying the other 5 correspondences, the other 5 parts? Will I come up with another triangle? So let's go ahead and proceed. One correspondence. I can make a correspondence between any 2 angles and any 2 sides. Okay, so the possible correspondences are a side correspondence for one side correspondence, and an angle correspondence. I'm going to draw my 2 triangles, ABC, and my triangle DEF, and I'm going to make a side correspondence, which means that they cannot vary. They must stay the same. I'm going to set this side, BC, equal to DF. Now, if I want to show that that sort of side correspondence is enough to force the other 5 correspondences to be the same, then that means I cannot create another triangle, a counterexample, where I do vary the other parts and the correspondence is maintained. So if I can demonstrate a counterexample or create a triangle where a new triangle DEF, where DF is still the same size as BC, then that means this correspondence test fails. I need to have more information. Just one side is not enough to establish congruence with the other two triangles, with the other triangle. Okay, so my alternate DEF will look like this. Back. So this is the original. This side has the same as that side. So I'm going to vary some parts here. I'm going to make EF shorter. Make it only this big. Okay, so there's F here. DF is still the same size. And because I made EF shorter, to complete the triangle, it looks like DE is different and angle D is different. Okay. What I've shown here now is a counterexample. I've kept my correspondence the same between DF here. They're still the same as BC, but I was able to manipulate or vary the other parts, the other 5 correspondences, by making angle E bigger and angle D smaller. By making, so notice that one's bigger. It's this big now, and it used to be this big. D is also smaller. That's this big now, but it used to be this big. EF has changed size as well. It used to be this long, now it's this long. Okay, because of those changes, I've completed a triangle, but have maintained the same side correspondence. And so because of that that counterexample, that means that one side correspondence is not enough to force the other 5 parts of the triangle, the other 2 sides and the other 3 angles, to stay the same. Okay? So the side correspondence is not enough. Now let's go with an angle correspondence. Okay, we call the angle correspondence A and the side correspondence S. Now the angle correspondence, which means that I'm going to fix an angle, just one, between 2 triangles that I'm trying to show are congruent. And I want to see if that will make the others, here's A, B, C, that will make the others, force the other 5 correspondences to stay the same. D, E, F. I'm going to try and do angle B to stay the same as angle E. So looking down at the, a triangle DEF that I'm going to vary, I'll construct it first, or draw it first, to be the same. Okay, and then I'm going to keep E the same here, but move the other parts. If I keep E the same, what can I do? I can open up angle F. I can extend ED. Let's go ahead and do that. Oops, eraser. Now the angle E still has to stay the same. So D's no longer be there. Let's make ED longer. Put D down here. Open up angle F. Okay. Notice that the angle has been preserved. What has happened to the other parts? Well, EF hasn't changed at all, so that's good. But DE has gotten longer. Okay, so this is longer. Angle F has opened up. And also DF has gotten longer as well. And angle D has closed up some. So F was more open, but then that forced D to be more closed. Okay, and because of those changes, my angle E has not changed at all, but I was able to manipulate some of the other correspondences and create a new triangle, DEF, that has the same correspondence, angle correspondence as the original, but different triangles. So that means it's not the same triangle. And thus I've created a counterexample. So if I just establish one correspondence, an angle correspondence or a side correspondence, that is not enough to force all the other 5 correspondences to be the same, and thus create a rule or test for congruent triangles. Now let's move on to 2 correspondences. Okay, so thanks for hanging in there with me, because they're doing awesome. If I establish 2 correspondences, either with angles, 2 angles, or 2 sides, or an angle and a side, between 2 triangles, is that enough to force the other 4 correspondences to be the same? Okay. So what do I mean? Well, 2 correspondences could be 2 angles. 2 angles equal. And I'm going to call that a correspondence. So 2 angles are equal. You can also have an angle on the side and also a which I would call the AS correspondence, or you can have 2 sides correspond. That's the side-side correspondence. Okay, so we'll get to those in a minute. Start with investigating whether 2 angles are enough to make 2 triangles congruent. So here's our triangle ABC. And here's our triangle DEF. Okay. And so the angles, I can pick any 2 angles. Pick this one and this one, angle B and angle A. They must stay the same. They must stay equal to angle E and angle D, respectively. Okay. Now, what else can I vary? I'll draw that in green. I can vary. I'm going to try vary angle DEF into a different triangle, but maintaining these 2 angles the same. And if I can, then that means I can that I've constructed a counterexample, and 2 angles is not enough correspondences to force all the 4 other correspondences to be the same, and thus have 2 congruent triangles. So I've drawn in green all the things I can vary. So what I'm going to do is I'm going to draw another triangle DEF, try to construct one where I can vary any of the 4 green parts, but must keep the blue parts the same. So what I'm going to do is I'm going to go ahead and try and draw this one the same. So here's my other triangle. I need to maintain this angle here and this angle here, but I can vary everything else. Can I construct another triangle where I maintain those angles but vary other things possibly? Okay. So let's go ahead and we can extend all of the sides and then keep the angles the same. So let's do that. I'm going to make this triangle bigger. Okay. So this, I'm going to extend DE, so I'm going to erase D. Okay. So D is the same angle. I'm just making everything else bigger. E is the same angle. So it's not quite perfect, but we're going to pretend that those are the same. Okay. Notice that all of my sides got bigger. My angle F is still the same, but it's okay that that the other sides got bigger. Okay. And because I've constructed a counterexample, of triangle DEF, I've got a different triangle with the same two correspondences, which means that those two correspondences aren't enough to force the other four correspondences to stay the same. Okay, so if I only do that, then that is not enough for a congruence test. So two angles aren't going to work. Let's try an angle and a side. If I, let's do angle dash side. Okay, so if I correspond an angle and a side, these two triangles, okay, so I'm going to do an angle and a side. I'll do this angle here, B and E, and I'll do this side here. Those have to stay the same. But what else can vary? What are the other four things that can vary? This side EF can vary. It can get longer or shorter. This side DF can vary. It can also get longer or shorter. And then these two angles, angle D and angle F, can also get longer and or shorter, open up more. Okay, so let's just pick one thing to do. Okay, so this has to be the same here. This angle has to be the same. This angle D doesn't have to, so I'm going to mark this one right here and this one right here. Okay. All right. Okay, yeah, so that has to be the same length there. So put our D here. Okay, so this one has to be the same. And this one has to be the same. That has to stay. Well, what can we do? Let's make EF longer and see what happens. EF goes down to here, but let's make it go all the way down this way. As far as we can go. Now, what did it do to everything else? I'm going to complete my triangle. I have not changed my angle or my side. That's still the same there, and that's still the same there. Okay, DF is now longer here, because it used to be this big, now it's this big. EF is also longer. Used to be this big, but now it's this big. Angle F is smaller. Used to be this big, now it's this big, skinny. And D has also gotten bigger, wider. It's this big now, it used to be this big. Okay. But notice that my angle E and my side DE have not changed at all. I was able to complete another triangle. Okay. And what this means is that this is the counterexample. Okay. It's a new triangle with the same correspondences. And thus those two correspondences aren't enough to show that the triangle is congruent, one triangle congruent to another. Okay, one more for these two correspondences, so we can correspond two sides. If we have two sides, we can call that side side. If there are two sides that are equal, will that force the other four, like the other side and the other three angles, to be the same? So we're going to make a correspondence with this side here and that side here. this side here and this side here. Okay, these two sides have to stay the same. What can vary on triangle DEF to make our counterexample possibly? So that side can change, this angle can change, that angle can change, and this angle can change. Okay. So even if we just extend so let's open up angle E a little bit. So instead of making it this big here, we're going to open it up and make it this big. Okay, so let me back up and redo that. Wide angle E. Okay, so this side has to still stay the same. We'll pretend it's the same length and same everything. Okay, opening up angle E to make it wider. Oops. There we go. Okay. And we're going to make angle side EF is still going to be the same. This has to stay the same there. Okay. Now when it's wider, here's D and F again. D and F is now longer. Let's see, DE is still the same, EF is still the same. D is, this angle right here is smaller. It's gotten small. So has angle F. And this one is wider, like we planned. Okay. I've been able to construct a new triangle that's different size and shape with the same correspondences that are marked in blue. This is my counterexample. So that means that the two sides two-side correspondences does not work. So I've proven that no way can we make two correspondences force the other four to become the same. So that means that we need at least three correspondences to possibly force triangles to be the same. All right, class, we are going to move to three correspondences. This is a type of investigation where we're going to make three correspondences between two triangles. Could be any of three of the six possible correspondences. And we're going to see if that will be enough to do a congruence test, a valid congruence test. Will three correspondences force the other three correspondences to be the same? Okay. And so as we begin, we want to kind of organize our exploration in a way so that we can take each case of three correspondences. There's probably going to be more than what we've seen before with one correspondence and two correspondences. First of all, each triangle has three sides and three angles. So let's start with that. What's a correspondence test? A correspondence that we can set up between three angles. Okay. So we can do. So let's make a list here. So angle is going to be the correspondence test between where we set up the three angles equal to each other. And then we see if we can vary the sides to make a counterexample. And if we can find a counterexample, the test is not valid because there's more than one possible triangle with the same correspondences. But if we cannot find a counterexample, then we can use that test to be a valid congruence test, which means that I can establish those correspondences, just three, and forces the other three to be the same. And then we can say that the two triangles are equal, or congruent. So what are the other variations of three correspondences that we can have? Well, we have three angles here. Okay, so we can have three angles equal to each other. We can also have two angles set equal to each other and one side. Okay, so let's think about the possible congruence test for that. Two angles and a side. So that could be angle angle side, or AAS. Okay? So that's any two angles and any side. Now we can also have a different type of correspondence test where there are two angles and a side, where we put the two angles on the side in the middle between the two angles. Okay, we call that angle side angle because it has two angles from the triangle and the including side that they adjoin. Okay. How else can we write three correspondences? Well, we have all three angles. There's two types with two angles in one side. We can also have two sides in an angle. Okay. Let's see. So two sides in an angle, so that'll be side, side, angle. Okay, that's SSA, where we pick any two sides in the triangle and then any angle. The other one is a little bit special, like angle side angle. This is called side angle side. We can pick any two sides, but the included angle is the one that will be part of this test. Okay. And once I've got all of those tests, that's all of those, we can have three sides. Okay. So that one is going to be the side, side, side test. Okay. So those are all of the ways that we can set up three correspondences. We need to take a look at each one to see if the other three parts of the triangle will be forced to be the same if we establish the first three to be the same. So the first one is the angle, angle, angle one. Okay, AAA test. So to do this, we're going to draw out our triangles ABC, DEF. Okay. And like before, we're going to draw out an alternate DEF and see if what we can vary here. What needs to stay the same. So in this test, or possible test, or this setup, we have three angles that can be the same. So that has to be set up like here, like we've done before. So angle A is the same as D, B is the same as E, and C is the same as F. Okay. All those angles have to stay the same, but what can vary? So I'm going to highlight that in green. That side DE can vary, this side EF can vary, and this side DF can vary. And so let's go ahead and see what we can do. When the sides vary, that means they can get bigger or smaller. And it turns out that we can make this, just like with the angle-angle investigation, we can make this triangle bigger on all three sides proportionally. Okay. So there's D, E, and F. Now all of these angle measures are preserved. Okay. And when all of the angle measures are preserved, okay, so this one's longer, this one's longer, and this one's longer. When all the angle measures are preserved and all of the sides are longer proportionally, we have another triangle that has the same correspondences as the first. Okay? Because they have two triangles that have the same correspondences as the first, that means that if you just set all three angles equal to each other, does not force all three sides to be the same. Okay? So this is going to be the counterexample triangle. Okay. And therefore, AAA is not a valid congruence test. All three angles there. Okay, next we did two sides in an angle. Two angles in a side, I should say. Okay, and this is the angle side test. Okay, so this is A, B, C, and D, E, F. We draw these two triangles, and we're going to make correspondences. Pick any two angles and any side. So we'll pick these two angles here, and we'll pick this side here. It cannot be included in between the two angles because that is the next test. Okay, angle, side, angle. All right, so these two angles in that side has to stay the same. So what can vary? Let's take a look at what can vary. We can vary this side here. We can vary this side down here. And we can vary this angle here. Now since F can vary, let's open up F and see what happens to our DEF triangle. Okay, so here's our DEF triangle. We can open up F. So EF is going to stay the same. Let's open up F to make it longer. DF can be any size, so we can open up as big as we want. Okay. And DE can be any size, so that's okay to do. Even though we've tried to keep EF the same size, something's happened to the angles though. Okay, so angle E is now become smaller. Okay. So because I opened up F and I closed my triangle, E is smaller and angle D is smaller. Okay. And DE and DF can be varying in size, so those are okay. But because I've made E smaller and D smaller, that violated my congruence establishment. And that means that the counterexample triangle cannot be created. Therefore, the congruent triangle must stay the same. Similar arguments can be made with the other parts, and so angle side is actually a valid congruence test. Okay. No counterexample triangle can be made if you vary the other parts and maintain the correspondence. So our next one is the angle side angle test. Okay, an angle side angle is set up like this. I'm going to put my triangles. Okay, and I'm going to make correspondences that have to stay the same. So I'm going to make an angle here. These ones, A has to stay the same as D. The side and this angle here. Okay, notice that I have AB as a side here to DE. That has to stay the same, and angle B has to stay the same as angle E. That is two angles and their included side. Okay, so that's why I have to use this side. What can vary? Let's go ahead and look at what varies to make a different triangle. We have DF can vary, EF can vary, and angle F can vary. Okay, so when we do that, let's go ahead and open up angle F again. Make an alternate DEF and see if that will work. Okay, so this can be any length, but we're going to keep it the same anyway. Open up angle F here. Okay, we'll open up angle F, make it bigger. Now DF can be any size, so we'll just put it this size. Make this one longer. DF is longer. Open this one, so it can be longer. This one's the same. But what happens when we try to close the triangle? Again. Now, even though it doesn't have to be the same, we'll go ahead and erase that. DE is longer. And we can't do that. This one's okay to be longer. E again has become smaller. And D has become smaller. Okay, and we can't do that. And so what we've done is we have created a violation in our correspondences. So this, if we open up F, the new triangle will not be a counterexample, it will not be the same with those correspondences, which means that, and similar arguments can be made for other parts of the triangle, that angle AS, the congruence test ASA is valid, because anytime you adjust the things that can vary or are allowed to vary, the things that are not allowed to vary, the correspondences, will be adjusted automatically. Okay, and so we cannot create a counterexample. So thus the test is valid. Okay, that was the two tests for two angles and a side. So now we got two sides and an angle. So we'll do side, investigate the side angle test. Correspondences, SSA. So we'll go ahead and draw our two triangles. Oops, take that one a little bit longer. And make some correspondences here. Okay, so I'm going to make this one the same as this one. And make this one the same as this one. Okay, so it could be any two sides, but not any angle. That can't be the included angle. It could be any other angle. So let's do angle F here. And angle C. All right, so we need to construct a new angle DEF and see if we can make it different. Okay. Then that one, okay. So let's be here. Okay. There's F, D, and E. What can vary? Well, we can vary DF. We can vary angle D. We can vary angle E. Okay. So EF needs to stay the same. Let's see if we can make a counterexample where it's the same correspondences. Okay, those have to be staying the same, but I can vary angle D and length DF. This one has to stay the same though. Let's make DF smaller. Okay, and as we make DF smaller, it brings this angle E, can vary, closed. Okay, closes angle E. So this side needs to stay the same. So we're going to put that there. Bring it all the way till we can get back to here, which we do like right here. Okay. Notice that I've kept. Okay. So if we kind of swing this one, swing over, we will get it to start at DF, but then it connects back to DF. But DF actually happens to be smaller, which is okay. That's part of DF can change. Notice that ED did not change. That's still that same size. EF did not change. That's still that same size. It didn't even move. And angle F also didn't move. So we still have two sides and an angle. But what we've done is we've created another triangle here. Okay, so I'm going to highlight that in orange. This is our DEF here. We've moved it to become this DEF, and notice that it is a different triangle with the same correspondences than your ABC. Okay. So this is not a valid congruence test, okay, because I've created the counterexample triangle. Same triangle, or sorry, same correspondences but different triangle. It did not fail like as in before. So side angle does not work. Okay, does not work. And you can know that it doesn't work because if you tried to do side angle And you know that you can't do that one because if you switch the letters around, it makes a bad word. Okay? You can't do bad words there. But there is actually one exception. So any two sides and any angle not included in the middle don't work except for once. One thing, one exception. Okay. If I have a right triangle, I'm going to draw a right triangle ABC here. Angle A is the right angle. I'll put it with a box. Okay. I need to look at the right triangle. And right triangles in math are special, so they have different parts, and their different parts are named. Okay. So this is the right angle. Of course. This side right here is called the hypotenuse. Okay. The hypotenuse is the longest side of the right triangle. It's also the side opposite the right angle. Okay, notice that it's opposite here. Okay. These other two sides are called legs. Okay. The establishment, the triangle congruence that you have to establish is okay, we'll pretend that those are the same. Actually, what I'm going to do is I'm going to move this over just a bit so we can get some more room here. This will need some room. Okay, so we'll pretend that those are the same. This is my DEF. Okay, we'll pretend that they're the same. Okay. So making my correspondences between ABC, I can make that those two, these are going to be the same size. This is going to be the same size here. These legs, the two hypotenuses have to be the same. The two legs have to be the same, just two of them. And the angle has to be the same here. It has to stay right angle. Okay. All right, so what can we vary? Well, we can vary this angle here and this angle here. And this side length here. Okay, so let's do a swinging thing again. We're going to take this one and keep it the same here and swing it around this way. And when I swing it around that way, all the way to here, notice that I have the exact same triangle. Okay, so it swung all the way down here. Alright, so it's still the same as ABC once I complete it again. So I swing this side down. Okay, I'm swinging this down here. Okay, it's going this way. It stops here. Okay, it completes the triangle. Okay, and notice that is the exact same triangle as triangle A, so I'm going to highlight that in orange as well. Okay, this triangle right here is the same as this one, so that means that there is no counterexample triangle done when I make the right angle. Okay, So right triangle is the key on this one. And we call this special case of side-side angle. Call it, because we'll name it right after the right triangle idea. Okay, the right angle, the hypotenuse, and the leg have to be corresponding, so we call it RHL. So that means RHL is a valid congruence test. Now, whenever I see in the homework a problem that has a right angle, then I call it RHL. I look for RHL first. Okay, moving on, we have the other case of two sides in an angle, called the side angle side test. So it's SAS. So this is two sides with the included angle in between them. Okay, so I'm going to draw my two triangles here. ABC, DEF. Okay. So what correspondence do I need to make? Well, I'm going to make this side here, this angle here, and this side here. They have to stay the same. Now, can I construct a counterexample triangle? Well, I maintain these correspondences. Okay, so DEF, let's see what we can vary here. We can vary this bottom side, this angle right here, and this angle right here. So these three parts at the bottom I can vary. Let's open up angle F and see what happens. I'm going to keep EF the same just for fun, but open up angle F. Now DF can be any size. Okay, so there's D down there now, and E is up here. So I open this one, and what happens when I complete my triangle? Oops. Okay, let's see. That's open. Okay, this one stayed the same here. That's good. This could be any size. That's okay. But D got smaller. ED definitely got longer, and E got smaller. Okay, and so these ones cannot happen. Okay, so I need that one to be the same, I need that one to be the same. Okay, it's okay if angle D got smaller, but since ED and angle E got changed, those correspondences were lost. Okay, and thus no counterexample can be made. Similar arguments can be made for the other parts, but in short, no counterexample can be made. And thus, every time we make a side angle side correspondence, the triangle must be congruent. The two triangles must be congruent. Okay. Last one. Those are great to hang in there. Three sides. If I establish correspondences between all sides of the triangle, leaving the three angles to vary, could I make a counterexample? Okay, all three sides have to be the same. Okay. Okay, what can vary? Well, this angle, and this angle. Okay. Let's go ahead and see what happens when I open up angle F again. Seems to do the trick. Okay, so this side I'm going to go ahead and keep the same. So we make that one the same. We're going to open up F. Okay, and then I'm going to go ahead and complete the triangle. Now D cannot be changed, so we need to keep D the same. Okay, so D's the same. It kind of swung down here. And that's okay, but we're going to connect E here, and E's definitely gotten longer. Okay. And because E is longer, my angles, it doesn't matter my angles, they can be any size. E's gotten longer, that violates my correspondence. And so no matter how I manipulate the angles, one of the sides will be violated in their correspondence, which means that they will no longer be the same length. Okay. Because of that, no counterexample can be made, and therefore side, side, side is a valid congruence test. Okay. All right. We've done a lot of thinking about congruence tests. What is the overall takeaway? The only congruence tests that worked were from three correspondences. Okay. So those are the only ones that we need to worry about. Angle, angle, angle. Angle, angle, side. Angle, side, angle. Side, side, angle. Side, angle, side. Oops. And from side, side, angle, we got RHL. Side, angle, side. And side, side, side. So those are all the those are all the possible ways to make three correspondences. Now, which ones were good, which ones were not? Well, angle, angle, angle was not good because we can make all of the sides longer proportionally. Angle, angle, side was good. Angle, side, angle was good. Side, side, angle was not good. With one exception, RHL. If I make the angle right, if I make the hypotenuses equal to each other in one leg, okay, that will work. Just one case. One exception. Okay. Side, angle, side did work, and side, side, side did work. Okay. So in your homework, there's a lot of tests to use. So look at the correspondences, and we'll look for which test is good. These are your choices. So this is like your toolkit for the next homework. So we're going to go ahead and go back to our handout and see how these work. All right, class. What we have here is we're going to start using the triangle congruence test that we discovered in our exploration. We need to first name the congruent triangles and state the reason why they're congruent. So we're going to go ahead and do that. First, we'll identify the congruent triangles or the triangles that we want to be are congruent to show they're congruent. And then we will do a process to establish congruency by identifying a test and then showing the correspondences. Okay, so in our first example, we have number 4 here. So let's go ahead and zoom in on that one. And what we're going to do is we're going to identify which two triangles are congruent. Okay, so we're going to have a red triangle and a blue triangle. Okay, so our blue triangle, we're going to identify both halves as congruent. So I'm going to outline this one in blue. And this one, red one, is also going to be the other half of the triangle. So these two halves we're going to show that those are congruent by picking out a congruence test. The congruence test that you choose will depend on what is given to you. Okay, so we have that list. There are 6 of them in that other list. There's several that are given here in the example of the directions. But what are we given here? We look at the marks that are given, or sometimes in the homework you'll have statements that tell you what's given. So the first thing that we have here is a mark on these two bottom segments, okay? We also have, that means that these two sides are congruent, okay? We also have a right angle marked. Okay, so I'm going to highlight that one again here. That one's marked. So that means that this other angle is right, okay? So we have 2 right angles there. So we have only 2 correspondences. And the third one is actually, since notice that AD shares both of these sides of the triangle, the 2 congruent triangles, the red triangle and the blue triangle. And so AD is going to be equal to AD on both triangles because they lie on top of each other, and we call that the common side. Okay? So let's go ahead and write down what we know. We have these two sides, okay, AD, and then we have the bottom of the figure, those, and then we have the angle in between them. So whenever I see the right angle, I try to see if I can fit right hypotenuse leg. So will right hypotenuse leg work? Well, in right hypotenuse leg, we need a right triangle, right angle, I mean. That's check. The H is for hypotenuse. And it looks like that the hypotenuses of this triangle are AB and AC. So that means that we do not have anything about with which to show that those two are the same. So therefore, right hypotenuse leg cannot work. So to back up here. So right hypotenuse leg can't work. So we have to go back to our more general ones. Notice that there is a side here that these two are the same, the angle between them, and that side. So let's go ahead and use side angle side. And in this handout, we're going to go ahead and just say use side angle side. You need to say what congruence test you're going to use, and then you're going to say which parts are congruent. I need first a side correspondence. Which two sides are the same? Well, we can go with the ones that we marked first on the bottom. So we can say that BD is equal to CD. You can name those segments in any order. Now, how do we know that those are equal? We have to put the reasons why in parentheses. The reasons why those are equal is because they were given. Okay. If there is a figure in the homework where the marks are already there or the statement is there, we say that the reason is given to us. Now I'm going to have to say what my angle correspondence is. Okay, that's in the middle, those right angles. Now we're going to pretend that both of the angles were given as 90. So angle, let's go ahead and name them an angle. So let's name this angle A and this angle B. It's a lot easier than with all the letters. Okay, so angle A is equal to angle B. That's what we're going to say is given. Now, in the homework, they might not give it to you, so you have to deduce it. But in this one, we're going to keep it short and just pretend that there was a mark there for angle A. Now, because, okay, and then moving forward, the last one is the side correspondence. The last side correspondence, again, was because those two sides were lying on top of each other. So we can say that AD is equal to AD because they're lying on top of each other. Other books call it reflexive, but we're going to call it common side. Okay. Now, once I've established these three correspondences, they have fulfilled the congruence test of side angle side, which means that all the other parts are the same. I know that this angle is the same as this one. I know that this angle is the same as this one. And I know that this side is the same as this side. Okay, everything in purple can now be derived because I said I made these three correspondences. So I made the correspondences, and the reason why they can be derived is because now the triangles are congruent. And so we're following the first part of the directions that says write down which triangles are congruent. So triangle ABD is congruent to triangle ACD. Okay, they can be given, the letters can be given in any order, and we make sure that we draw our squiggly in this way. So we put our equal sign and then we squiggle, starting down at the bottom and going up. Okay, when we say that those are congruent, we have to tell the reason. And we're going to repeat our reason from above by side angle side. Okay, I'm going to go ahead and show you number 5, and then we can have you try 6 and 7 on your own, and then I'll go ahead and then show you from the video what they would be. Again, number 5, we're going to identify two congruent triangles. So I'm going to take the left and right sides again, make the left side blue, that's my blue triangle, and then make the right side red. And what have they given to us? They gave us that these two segments are the same, and these two segments are the same. They've marked them with marks. Okay, so as far as I know that there's only two segments marked, and I need to deduce the third part because every triangle congruence test has to have at least 3 correspondences. So which one should I use for these ones? Well, I have two sides, and I can use side-side angle. Nope, I can't actually, that's bad. I can use side angle side, but what do I know about these angles here? Nothing. They're not given to me. The included angles are not given, so therefore I cannot use side angle side. How about let's look at this side right here, the third side of the triangle. Can we deduce that that side is equal to that side? Yes, we can. So side EG from the blue triangle is the same as side EG from the red triangle by common side. So once we have those 3 parts marked, we know that our congruence test is side, side, side. So we're going to use side, 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 and we need to identify all of the side correspondences. So the first side correspondence is FG is equal to HG. That was given. The next one is FE is equal to HE. That was also given. Okay, the first one with 1 mark and the second one with 2 marks. The third one we deduced that EG is equal to EG. That was from common side. Okay, and because we have common side, we have all 3 correspondences now established. Triangle, we can say that the triangles are congruent because in our previous exploration, all 3 sides had forced all 3 angles to be the same. So therefore the triangles are congruent. So we have EFG is congruent to triangle EHG. Okay, by side, side, side. You have to put the reasons there. Even though I stated it above, you have to state it again at the end. So it's for completion. Okay, so 6, 7, and 8 we have. Let's take a look at 6 and go ahead and pause the video. Try 6 on your own and then come back and play and we'll see how it works out. Okay, welcome back. First we're going to divide up our figure into 2 congruent triangles. So we have a blue triangle and a red triangle. And we are going to mark which ones were given to us. Now, this right angle was given to us earlier, but I overwrote it, and so is this one. Those 2 right angles are given to us, and we also have these 2 sides given to us. So we have a blue triangle and a red triangle. The right angles are given to us, so let's try and see if we can get right hypotenuse leg, because that's my go-to whenever I see right triangles. I might not get it like in the first example, but most of the time it actually does work out. So we're going to try for right hypotenuse leg. Now, the right angles are given to us. They're marked in boxes here. The other parts here that are given, there's 2 marks, are actually the legs, okay? Because the hypotenuse is what is opposite the right angle. So these are the hypotenuses, those long ones along the points IK. Okay? And since they coincide, they're 2 diagonals right on top of each other. We can mark them with 1 mark, and then we have a hypotenuse equal. So we have enough information to use right hypotenuse leg. So let's go ahead and write our correspondences in the order that they're given in our test. Okay, so with right hypotenuse leg, the right angle is angle IJK. So let me go ahead and name it something. I'm going to name this A and this B, because IJK and all that is a lot of letters. So in my right angle, I have angle A is equal to angle B, which is equal to 90 degrees. I want to and we put the reason as given. I want to reinforce when I use right hypotenuse leg that is, and emphasize that is 90 degrees. The hypotenuse is IK is equal to IK. Okay, that was not given to us, but we deduced it by using common side. Okay, and then the leg that was on there is JK. Oops, is equal to IL. So the top side and the bottom side, those are the legs, and those were given to us. Okay, so because we established that those three correspondences, our two triangles, the red and the blue one, are equal to each other, congruent to each other. So triangle IJK is congruent to triangle ILK by RHL. Okay, so we have that one done. Go ahead and pause the video, try number 7. All right, welcome back. Here is number 7. We're going to go ahead and separate our two triangles into the blue and the red triangle. Okay, we got two triangles here. We'll review which parts are marked on here. We are given that this side is equal to this side. This side right here is equal to this side. And this angle is equal to this angle. Okay. And so it looks like we have side angle side because everything's given to us. So we're going to use side angle side. Oops. Okay, our first side is NM equal to PQ. So those are the ones with one mark on them, and they were given. The next side is side angle side. So let me go back. I like to follow the order of the letters here. So let's do an angle correspondence next. Angle M is equal to angle Q. So let's go ahead and, for good measure, we'll put A and B in there, and A is equal to B, given. Because in the homework it gets pretty crazy with the angles, so let's go ahead and name those letters. The next side correspondence will be, the last one thing is going to be OM equals OQ. And that was also given. So these, we're lucky that all three of those were given to us. Because we did side angle side, valid congruence test, we know that those triangles are congruent. So triangle NMO is congruent to triangle PQO by side angle side. Okay. And our last one down here, number 8, we're going to identify two triangles, red and blue. And we're going to identify the marks and see what kind of congruence test we can get from them. Okay, use your marks to and givens as clues to know which triangle test to use. Have all the 6 triangle tests available to you so you can know what your options are. We're given that this right angle is equal to this right angle. Those are right angles, never mind. So if this is a right angle here, then we can actually deduce that this one's a right angle. This side is the same as this side. Okay. So those are the only 2 parts. We need a third correspondence. Well, in the past, those parts that coincide were helpful, so we can deduce that RT is equal to RT from the blue triangle is equal to RT from the red triangle. And therefore we have three correspondences. Whenever I have right angles, my go-to is to see if I can do right hypotenuse leg. So I have my right angles here. This one I'll have to deduce because it wasn't there before. And I have my leg hypotenuses right here. They're opposite the right angles. They're also the longest side. Okay. And my legs are just any of the other two sides. So we have a condition where you can use right hypotenuse leg. Now for the right angle, I have to tell you that I made up the other right angle A on this one. Okay, but in the homework you can't do that. In the homework we're going to pretend that this last one is like the homework, where we don't make up a right angle, we have to deduce that it is right using angles on a line. So this is our first case where the category of angle will be longer than one entry, than one statement. Okay, so it will take a couple statements. And in the homework, use these as categories, and they could be long or they could be short. So the right angle is the first thing that we're going to do. And in the right angle category, I know that angle RST is right. We're going to call that angle A. This one we'll call angle B. But angle B I don't know is right. So we're going to call this one angle C. So I know that B and C are angles on a line, so that's where we're going to go here. We're going to say that B plus C is equal to 180, okay, from angles on a line. I know that C is 90 degrees already. So B plus 90 is 180, subtract 90 from both sides. B is going to equal 90 degrees. Okay, so which is A is equal to 90 degrees. That means that they're both equal. Okay, now the reason why B is 90 now, but A is 90 because it's given. And so A equals B equals 90 degrees. Now what you need is you need to say A equals B equals 90. And all the other ones you need to end up with A equals B or whatever angles are equal. Now let's go with the hypotenuse correspondence. Hypotenuse correspondence was RT is equal to RT. The leg correspondence was ST is equal to UT. Oops, why is RT equal to RT? Well, that's common side. Okay. And ST is equal to UT because it was given. Okay. Now I have my right hypotenuse and leg correspondences made. Time to say which triangles are congruent. So triangle RST is congruent to triangle RUT, and that's by RHL. Okay, all right, so that's our handout part, and we hope that you enjoyed some part of this lesson. Very long, but very good. We'll go ahead and close this video, and the next video will be about some example problems from 4.3, which pretty much all that is applying the congruence tests to some sample figures like we've seen in the past. All right, so please let me know if you have any questions.